So really looking at this chart, we can talk about, let's say pi over 6. Well, sine of pi over 6 would be 1/2. Because we can look at the unit circle where it says pi over 6, 30 degrees, and sine is going to be the y. So it's 1/2. Six would be square root 3 over, and tangent of pi over 6 now it would be 1/2 over square root 3 over 2, yes? Now we have another little chart on that reference sheet. I'd say the other side, or other side of where your finger's pointing.
Here?
Tangent of pi over 6.
Square root 3 over 3.
Now we come over here for cosecant. Because CSC, again, as we talked about, cosecant is the opposite of what we think. Because we normally think you would be talking about cosine, but it's actually dealing with sine. So it would be the flip of 1/2, which would be 2. Secant of theta would be 1 over the square root of 3 over 2. This one's a little bit harder to see. It ends up being 2 square root of 3 over 3. Because we can type that one in. So we do the fraction 1, or secant is the same as 1 over cosine. So we flip it. Or essentially, we can flip it if we wanted. So I could have flipped, instead of doing 1 over, what we could have done is 2 over the square root of 3, because it's the flip. Then we have to rationalize the denominator, which would be 2 square root of 3 over 3. In cotangent, we could do the same thing. 3 over the square root of 3. It actually simplifies to being just the square root of 3. Does that make more sense? So a lot of this is just using that reference sheet. Now, pi is on there. So most of these here are on that sheet. Yeah? Pi is 180. And we can get those there. Now, the domain and period of sine and cosine. The domain of sine and cosine is the set of all real numbers to determine the range of the two functions considering the unit circle as shown here. Now, by definition, sine t equals y and cosine t equals x, because x and y is on the unit circle. We know that y is between -1 and 1, and x is between -1 and 1. So the values of sine and cosine also range between -1 and 1. So the numbers that are coming out, sine and cosine, will be between those two values. But the angles that we plug in, we can plug in the angle, but the values that come out of it cannot exceed -1 and 1. It'll be somewhere around here. Questions on that there? The values of t plus 2 pi and cosine of t plus correspond to sine of t or cosine of t, because anytime I add 2 pi to it, I'm getting back to the same point on the unit circle, or the same value, because it repeats every 2 pi. So by definition, this is a periodic function, because anything that is considered a periodic function repeats a certain period. A period is the amount of time for a function or a graph to cycle. For the domain, function is periodic when there exists a positive real number c such that f of t plus c is equal to f of t. For all t in the domain of f, the smallest number c for which f is periodic is called the period of f, the amount of time that it takes for a function to repeat. We call it periodic. Actually, we call anything that has a cycle a set amount of time for it to start to finish is called periodic. We also get period. A female menstruation cycle is on a period. It repeats every so often. That's actually why it's called a period. So it's kind of dealing with those cycles. Does that kind of make sense? It's just anything that cycles. Now, we know that a function is even and odd. Didn't we remember dealing with this here, plugging in x and negative x and seeing how they worked? Because we did this with f of x. If it's equal to f of negative x, then it's even. Negative f of x is equal to f of negative x, then it's odd. Now, cosine and sine functions, cosine and secant functions are even. Sine and cosecant functions and tangent and cotangent functions are odd. So cosine of t is equal to cosine of, so cosine of negative t is equal to cosine of t. Secant of negative t is equal to secant of t. Sine of negative t is equal to negative sine of t. And tangent of negative t is equal to negative tangent of t. And the same for cosecant and cotangent. Any questions on this here? Now, a lot of what we'll get into, especially with this here, is going to be it's going to seem very tedious. I'll be honest with you for that. Because not the graphing calculator, the TI-30XS, the simple, cheap calculator that you can pick up for Walmart for $15, or pretty much any calculator you can pick up from any convenience store, any scientific calculator you can pick up at any convenience store will do sine, cosine, and tangent. So a lot of what we cover in this here is not going to make a whole lot of sense. This isn't, what I'm pulling out isn't the correct chart, but you've seen numbers like this here. Seen pretty much a list going down. They had these. This used to be the way that you would find sine, cosine, and tangent, is you would have a table, and it would list across the top. So the first one would be degrees or radians, and then it would have sine, cosine, tangent, secant, cosecant, cotangent, if you were lucky, or it just had sine, cosine, tangent. And you would have to use this chart, and it would normally go to about either 45 to 90, actually probably go down to 90 degrees, positive only. And that's what you had to use to be able to solve sine, cosine, and tangent. So, for us, it doesn't mean a whole lot that cosine of negative t, or a negative angle, is equal to cosine of the positive angle. It doesn't mean anything for us, because I can type in cosine of negative 30 degrees. It'll give me the answer. I can type in anything I want, or cosine of 30. You can type any of those in. But if we didn't have that, knowing that if I'm trying to solve for cosine of negative 45 degrees, that cosine of negative 45 is the same as cosine of 45 degrees, then I can look on my chart and find that answer. So that's where a lot of these theorems that we're going to start delving into in this chapter are going to be helpful. And I have an entire list, reference sheet for y'all. Now, because pi over 13, and this is delving into this, and dealing with the fact that sine and cosine of theta plus 2 pi n is the same as just theta, we can find these answers. Nope. Because 13 pi over 6 is equal to 2 pi plus pi over 6, you have that kind of this follows along. So we could take cosine or sine of this. Because I could do cosine of 2 pi plus pi over 6. Well, that's just the same as saying what? Cosine of pi over 6. And what is cosine of pi over 6? Yeah, right there. Now, if your calculator is already in radians, go on and do cosine of 13 pi over 6. Sine 13 pi over 6. Enter. So we get that there. Oh, mode. Didn't like it. Square root 3 over 2. Yes? That's the marvels of these calculators. It doesn't matter what the angle is, we can still find it. So a lot of this stuff here is neat and kind of works out nicely, but we really don't need it anymore because the calculators will do this. The calculators will do any of these. For instance, to evaluate, now these here you're going to need for it. Now, when calculating secant, cosecant of pi over 8, use the fact that cosecant is equal to 1 over sine of pi over 8. And then you can enter it in using the keystrokes. These here are not the same. What is that actual, what is this, the left side of this actually is? This is the inverse. That is the inverse, so we're not actually using that. Now, you can use this button here. Because it works out that sine these are not the same. Because the second one is to the negative first power. First one's not. So you can almost do sine of fraction pi 8, close parentheses, to the negative 1. Ah, I see what I did. So to do that, we've got to put parenthesis sine pi over 8, close parentheses, inverse. Let's see here, sine of pi over 8. Yeah, you get 2.613112.593. Yep. That's it.
Wait, how did you do that?
Parentheses, sine, close, or open parentheses, pi divided by 8, close parentheses, inverse, enter. Or you can do 1 over. Now it works out pi over 8, if you look on the unit circle, isn't one of our numbers. Pi over 8 is not 1, so it's not going to give us a nice number. 2.6131259. Well, sine of 2 pi over 3, we can just type it in. Cotangent would be 1 over tangent. And we would just type these. If it has pi or a number, if there is not a degree marker, it's in radians. If there is not a degree marker, it is in radians. Any questions on this here? And it looks like that is it. So let's look at the assignment here because we'll do some from the assignment. Kind of looking at it and seeing. So if we start off with 5 through 12, odd, because number 5 this is at the point 5, 12, or
5 over 13.
you're good. And that's the point, yes? So we need to find out what R is, the hypotenuse. Well, R is actually going to be the square root of x squared plus y squared. Because 13 squared is 169. They both have 13. 12 squared is going to be so sine of theta is y over r, yes? Well, y is over 1, which is just so in problems 5 through 8, find the exact value of the 6 trigonometric functions of the real number t. So it's only to find sine, cosine, tangent, secant, cosecant, and cotangent. R is 1. So it worked out when we did this here, we got 1. Now tangent theta is going to be sine over cosine 5/13 over 12/13, which will actually work out to be 5/12. And you can plug that in. I'd plug that into the calculator, it'll tell you. Now these here, secant, cosecant, and cotangent, are actually going to be pretty easy for this here, because I'm flipping this. So instead of it being 5/13, it's 13. And that's it. 5 and 7. Well, not just 7. In exercises 9 and 11, find the point xy on the unit circle that corresponds to the real number t. So 9 and 10, you're finding that xy coordinate point, which is really, because this coordinate point here is really cosine of theta, comma. Yes, if it's on there, find it on there. Pi over 2 is on there. 5 pi over 6. It is on there. Pi over 2?
It's not here.
In exercises 13 through 22, evaluate, if possible, the sine, cosine, and tangent at the real number. So you're only finding 3. So cosine, sine, and tangent at pi over 4. Negative pi over 6. Negative 7 pi over 4. 11 pi over 6. So the negative ones, I would add 2 pi to it to get the coterminal angle and go from there. Questions on this so far? So 5 through 12. Oh. 5 through 11 odd. I'm not making you do all those. 5 through 11 odd. 16, 18.
Okay, that's good.
24 through 36 even. Evaluate, if possible, the 6 trigonometric functions at those values. Evaluate the trigonometric function, if possible, if it's period as an aid.